At Long Key on September 2nd, 1935, hurricane winds suddenly collapsed. For 55 minutes, observers could see stars overhead, even as one of the most intense hurricanes ever to strike the United States passed across them. Then the wind returned from the opposite direction with full force. That pause is the clue. In a mature hurricane, the fiercest winds and rising clouds can organize into a ring around the center, while air inside that ring slowly sinks, warms, dries, and clears. So how does a storm build a calm hole inside its most violent core? Start with the simplest picture. Imagine looking straight down at a hurricane. Right at the rotational center, the wind is not at its maximum. Move outward, and the wind gets faster. Keep going, and eventually you reach a ring where the strongest winds are concentrated. Meteorologists call that the radius of maximum winds. For this story, think of it as the peak wind ring. That immediately solves one part of the mystery. The center can be relatively calm because the most violent wind is not sitting on the center point, it is wrapped around it. But that still leaves the harder question. How does the storm build such an intense ring in the first place? Near the ocean surface, hurricane winds do not move in perfect circles. Friction with the surface slows them just enough that they also drift inward toward lower pressure. So picture rotating air tracing a spiral, not a circle. Each turn carries that air closer to the inner core. Now take one ring of rotating air and move it toward a smaller circle. Its rotation can speed up. The technical idea behind that is angular momentum. Moving spin inward helps strengthen the wind closer to the center, but a hurricane is not a frictionless figure skater. Near the ocean, friction is constantly taking momentum away. Modern research shows that both this inward flow and heating inside the storm help control how the peak wind ring contracts and strengthens. So spin carried inward is part of the answer. It is not the whole answer, because faster wind alone does not clear an eye. The next step is vertical. As a hurricane intensifies, the thunderstorms around its inner core can become deeper and more organized. Instead of scattered towers firing in different places, more of that activity wraps around the center. Eventually you can picture a towering circular wall of rising clouds surrounding the middle. That is the Eyewall. Modern hurricane aircraft have shown that intensifying storms tend to have stronger and deeper inflow near the surface, stronger average rising motion in the eyewall, and more of the circle around the center filled with heavy precipitation than storms holding steady. In other words, the inner core becomes more organized in 3 dimensions. Air spirals inward near the ocean, then it rises violently through the eyewall, and the strongest thunderstorms increasingly occupy the ring around the center. Those thunderstorms are not just moving air upward, they are also releasing heat as water vapor condenses and freezes inside them. That heating helps reorganize the hurricane's inner structure. Picture the airflow now as a full loop. Near the surface, air moves inward. In the eyewall, it rises. High above the storm, it spreads outward. And inside that organized circulation, the central part of the hurricane becomes unusually warm aloft compared with its surroundings. Meteorologists call this a warm core. But the eye does not suddenly turn a cold storm into a warm one. Tropical cyclones are already warm core systems. What changes as the inner hurricane becomes more organized is how concentrated and structured that warm center becomes. And once the eyewall is strongly established around the middle, the air inside that ring begins to behave very differently from the air inside the thunderstorms. The eyewall is a place of powerful rising motion. Inside the eye, air can slowly move downward, not as a giant column crashing from the top of the hurricane all the way to the ocean, much more gradually, and as that air sinks, pressure around it increases. The air warms. As it warms, its relative humidity falls. Cloud becomes harder to maintain, so the center begins to dry out. Deep cloud thins, and under the right conditions, the sky can open. That is how you can stand beneath a violent hurricane and suddenly see stars. The surrounding storm has not switched off. The air inside the ring has simply entered a very different part of the circulation, and this slow sinking air does not explain the hurricane's entire pressure drop either. It helps explain the warm, dry structure inside the eye, but it does not explain the hurricane's entire pressure drop. At this point, the eye looks almost inevitable, but it is not. Hurricanes do not all reveal their eyes in exactly the same way. Satellite observations show at least 2 distinct routes. In one, Thunderstorms are already wrapped around the center, and cloud inside that enclosed region gradually clears away. The whole becomes visible from within. In another, the center is not yet fully enclosed. Bands of thunderstorms continue wrapping around it until they close the circle. The eye emerges as the ring itself is completed. So even when two hurricanes eventually show the same familiar shape, a bright circular eye surrounded by towering cloud, they may not have arrived there through the same visible sequence. And there is another complication. An organized eye can exist before satellite images show a perfectly clean opening. Aircraft observations can detect that inner structure earlier, so the moment a satellite picture first shows a neat round eye is not necessarily the moment the eye was physically born. That matters when we return to 1935. There were no hurricane satellites looking down at the Labor Day storm. There were no aircraft flying through its inner core. What we have instead are observations from people beneath it, pressure measurements, historical weather records, and modern reconstruction. And that modern reconstruction shows just how extreme the storm had become. Over one 24-hour period, NOAA's current analysis takes the hurricane from about 90 knots to 160 knots. That is an increase of 70 knots in a single day. By today's terminology, that is rapid intensification. At landfall in the Florida Keys, the storm is reconstructed at 160 knots, roughly 185 miles per hour. Its central pressure was 892 millibars, and the reconstructed radius of maximum winds was only about 5 nautical miles. That does not mean a 5-mile eye. It means the peak wind ring itself was extraordinarily close to the center. The wind estimate and that tiny radius are modern reconstructions from the surviving historical evidence. They were not measured directly inside the storm's core in 1935. The 892 millibar pressure is different. That reading has unusually strong instrumental support from the historical record. Put those pieces together, and the long key observation stops looking strange. A brutally compact hurricane approaches. Its strongest wind is concentrated in a tight ring around the center. Deep thunderstorms rise around that ring. Inside it, the air is warmer, drier, and slowly sinking. Then the center passes overhead. The wind drops. The cloud opens enough for stars to appear. And 55 minutes later, the other side of the Eyewall arrives. The calm did not mean the hurricane had weakened. It meant the observers were inside the one place where the storm's most violent winds were wrapped around them instead of directly over them. And the eye itself did not cause the storm's explosive strengthening. Eye formation and rapid intensification can appear together because both are tied to a highly organized inner core, but one is not a simple switch that automatically produces the other. Over Long Key, stars were visible above the eye before violent wind returned from the opposite direction.